Alrighty, so if you're watching this video, it is because you are doing the covalent bonding worksheet, and this is going to go through several examples for you so you have a better idea of what I'm expecting and maybe what some of these columns are asking for. Very similar to the ionic bonding worksheet if you've already looked at that one. The number of the protons and the number of electrons and the number of valence electrons you should all be able to get from your periodic tables. We've kind of written those things in before. So carbon, if you look at where it is on the periodic table, it's atomic number 6, which means it has 6 protons. And because you do not see a charge or anything over here on carbon as an element, that means its protons and electrons are equal. It's a neutral element. So 6 protons is going to be 6 electrons. Because of where carbon is on the periodic table, it's in group 14, that means that it has 4 valence electrons. Now, as far as this last column, this is different if you've already watched the ionic video. This one is asking you for the number of electrons to fill the outer shell. So our magic number is 8. I'll put that on here. Magic number is 8. You want the number of valence electrons that the element already has and the number that you're writing here to equal 8, except for hydrogen. Hydrogen is the only exception. It is happy with just 2 electrons because it only uses the first energy level, which holds 2. All the other energy levels hold 8. You might remember that from that element builder activity you did for e-learning. The first energy level holds 2, the second one had 8, the third one had 8. So 8's pretty much the magic number except for hydrogen. So in order for carbon to have a full outer shell, it needs 4 more, and then it will have it will be full and it will be happily bonded. Now, chlorine, on the other hand, chlorine is in group 17. It actually has the atomic number 17, so it has 17 protons. And again, because protons are equal to electrons, it has 17 electrons as well. The number of valence electrons in the group 17 family would just be 7. And so in order for chlorine to fill its outer shell, it only needs 1 more, so to meet that magic number of 8. So again, hydrogen is the exception. Hydrogen is happy with 2, and everything else, though, has to be 8. All right, so moving on. This is actually an extra problem that is not in your worksheet. I'd highly recommend that you jot the notes somewhere so that you just have an extra example of kind of what covalent bonding looks like. You are going to start again by writing down the elements as symbols and putting the right amount of valence electrons around them. So nitrogen has a total of 5 valence electrons, so we're going to draw 5 dots around nitrogen. Again, it doesn't matter where you put the dots. I kind of already have an idea of how this is going to bond, so I'm kind of purposely putting them here on the insides of each other so they're pointing toward each other. Now, with covalent bonding, this is about sharing. So you are not going to be drawing any arrows because arrows show that one electron is leaving and moving somewhere else. So these electrons aren't going to move to another element. They're going to be shared back and forth between the element, but they're not permanently leaving. So whenever we show a covalent bond, you're going to do that with an arrow. Now again, the magic number is 8, so we want all elements except for hydrogen to have 8 total electrons. So because nitrogen has 5, it really needs to share 3 more electrons in order for it to have 8. So to show that, we are going to draw a circle, and your circle needs to include 1 electron from each element. And what that means is that these electrons can freely go back and forth between these 2 nitrogens. So this electron over here on the nitrogen that's on your right is actually going to be over here around nitrogen sometimes, and this electron on the left nitrogen is going to be over here on the right nitrogen. And they're just going to go back and forth. All right. Now, at this point then, this nitrogen has 5 total electrons of its own, the original 5 that we drew, and it is sharing 1 from the other nitrogen. So right now, this nitrogen's only at 6. And this nitrogen here on the right is also only at 6. So again, our magic number is 8. Okay, we're not finished with this picture until we can get to 8. So we want to share again. Okay, when you share twice, this would be called right now a double bond. Okay, this electron can go back and forth between. You don't have to draw the arrows in the circles. I'm just drawing them there to prove a point that the electrons are being shared back and forth. So again, if we do a count of where we're at, nitrogen has 5 of its own, its original 5 that we drew, and it is sharing number 6 and it's sharing number 7. So we're still not quite at 8 yet. This nitrogen over here has 5 of its own and it's sharing number 6 and 7 from over here. So neither nitrogen is at our magic number of 8. So we can go ahead and share them again. Okay, they have another set of electrons. Now, since I have a total of 3 circles, this is what is called a triple bond. And those we don't see a lot of. We see single bonds, we see double bonds, and triple bonds. And that's really as high as we're going to be going is triple bonds. But the same type of thing. It has 5 of its own. It's sharing number 6, number 7, number 8. So we hit our magic number of 8. This nitrogen over here on our right has 5 of its own original, and then it's sharing number 6, number 7, and number 8. So this is a completed picture. What I want you to do next is get rid of the dots and get rid of all of the circles. Redraw just the 2 original elements. And this time, every single place that you had a circle, I want you to draw a line. Okay, so that represents one bond, the top bond that we have. We also had a second bond where they were sharing number 7 electron here. And there was even a third circle, a third bond. So in this case, we're going to have 3 lines. So there's our triple bond, 1, 2, and 3. And lastly, you're going to give me the formula. So we have N, and how many N's do we have in our total picture? We ended up only just with the original 2, so that is called N2. All right, these 3 parts need to be in each one of your sample problems in order to get full points. All right, so let's take a look at one that's actually on your worksheet, problem number 2. This one has hydrogen and oxygen in it, so we are going to start with drawing out the symbol for hydrogen. Hydrogen only gets 1 dot. Oxygen has a total of 6. Now remember, hydrogen was an exception element. It is happy with 2. When hydrogen hits 2 electrons, it is done. Oxygen, though, has to get to 8. All right, so we always start off by at least bonding them 1 time. Okay, these elements can always bond once. Some of them are done. At that point, other elements like that nitrogen one still want to keep bonding. So let's take a look at what happens here and see if we're finished or not. Hydrogen's happy with 2. Well, take a look. It has 1 of its own, and then it's sharing the second one. So hydrogen's done. It has the 2 electrons it wants, so we cannot draw any more circles around hydrogen. It's done. Oxygen, on the other hand, has 1, 2, 3, 4, 5, 6 of its own, and it is sharing the 7th one, this electron that's on hydrogen. So oxygen's only at 7. We haven't hit 8 yet. But the problem is that with this picture, there's really nothing more that we can do because this hydrogen's done. Check it off. Finished. But oxygen's not. So we are going to have to add another element to the picture. Again, you're only allowed hydrogen or oxygen. You can't add any other elements off the periodic table. Hydrogen and oxygen are all you're allowed. Oxygen would be happy if it had 1 more electron because it's at 7. And hydrogen is going to be happy with 1 more electron. So we're going to go ahead and draw in another hydrogen. Okay, and it doesn't matter, you can put it down here, down below it, over here, wherever. But hydrogen's going to have 1 dot, 1 valence electron. And again, this hydrogen is going to want to be happy with its 2. So if you draw a circle between hydrogen and that original oxygen, we have 2 electrons. So this hydrogen is done. And now let's take a look at oxygen. We have 1, 2, 3, 4, 5, 6 of its own original electrons. It's sharing number 7. It's sharing number 8. So oxygen has 8. So now oxygen is done. Should be a check mark. It's good. Again, just like nitrogen, I want you to take away the dots. I want you to take away the circles. And wherever you drew your elements, just kind of redraw them. I drew mine kind of in a line, so I'm just redrawing them in a line. And anywhere there was a circle, it is going to become a bond. Now notice that between this hydrogen and this oxygen, sorry, poor choice of symbols there, I don't want it to be a dot, it's not a valence electron. Let me just get rid of it so we don't have any confusion, okay? All right, so there is a bond that formed between hydrogen and the oxygen in the middle. So we're going to draw one line. That is called a single bond because there's only one line between them. Oxygen and this hydrogen, the second hydrogen, also form a bond. There's one circle here, so I'm going to form one bond over on the other side. So oxygen has two bonds around it, one bond to the hydrogen on the left and one bond to the hydrogen on the right. Now, as far as your final formula, we have two different elements in here. Neither one's positive, neither one is negative, so how do we know which one to write first? I go ahead and write them in alphabetical order. That's usually pretty safe right now. So H comes before O, so we're going to put H first. And how many H's do we have in the picture? We have 1 and 2, so we need to put H2. And then oxygen higher up in the alphabet there. We only have one of them, but we don't write ones. It's understood that since we drew the O that there has to be at least one of them. So these again are the three pieces that you need to have in order to get full credit. And you're going to work through the rest of these on your own. Again, please email me if you have questions so that I can help you, because when we come back we have other things that we're going to be moving on, and I want to make sure that you're getting help now while you're in class working on these. So please email me if you need help.